Alright, hello math fans. Today we're going to work on exponents, and we already worked with adding and subtracting variables with exponents. So let's just kind of review that. If I have 2x plus 3x, remember that's the same thing as saying, hey, you've got 2x's, I'm going to give you 3 more x's, so how many x's do you have? You have 5 x's. You don't have 5x squareds. Remember that, it's really important. Okay, you don't have 5x squared, you just have 5 x's. Okay, so if I give you 2x plus 3x squared, I can't add those together because, remember, those are not like terms. In order to have a like term, you have to have the same variable and the same exponent. That's an exponent of 1, that's one of 2. That's why you can't add those, you can't simplify that. Okay? Today what we're going to do is we're going to start out with multiplication with exponents. So let's give that a shot here. If I have x to the third power, do you remember you can write that as x times x times x? And if I have x to the second power, that's x times x. So if I tell you what's x squared times x cubed, that's like saying x times x, and then x cubed is x times x times x. So if you count, you got 5, so it's x to the fifth power, not 5x. Okay, it's x to the fifth power. Well, that's great to know. You can write it out and then add them up. But obviously, you want to do that every time. And if you've already seen what we're doing here, is there are 5 of those x's. That's why it's x to the fifth. So when you multiply exponents or variables with exponents. So right here, variables with exponents. What you do is you add the exponents. Okay. Now a couple things. First of all, it has to be the same variable. And I'm going to put also in slash same number, because we're going to actually put numbers as the instead of an x. All right. So in order to, when you do these, again, they have to have the same variable and the same number, and that's what I mean by number. Let me talk about this. So if I have x to the fourth power or 2 to the fourth power, that's what I mean. Those have to be the same in order to add the exponents together. Okay. So I've got this lesson is actually a lot of different examples, and just some tricks, some tips on how to be successful. So let's do a couple problems here. If I have x to the fifth times x to the seventh, well, that's x to the 12th. Okay, pretty simple. Okay, I can use any letter, z to the third, z to the 10th, z to the 13th. Okay, now be careful, because if I have y times y to the fifth, remember, this has an exponent of a 1. If it's just y, that's the same thing as y to the first power. You got to remember that, because otherwise you think it's a 0, and then you say 0 plus 5 is 5, and it's the wrong answer. We will get to y to the 0 power at another time. But for now, y just means y to the first, so that's equal to y to the sixth power. Okay, pretty simple. If I have a number, so let's say I have 2x to the third, and I'm going to multiply that by 5x to the seventh power. Well, let's make it 17th so it doesn't get too nasty here. What you're doing is you multiply the coefficients together. So that's 10. That's like normal. And here is where I look at I have 2 x's here. X to the third, x to the 17th, so it's 10x to the 20th power. And that's your answer for that problem. Okay, so you multiply the numbers together, and you add, and you look at the variables, and you add the exponents of those variables together. All right, I can also have x to the third times x to the fourth times x to the fifth. I can have as many as I want multiplied together. As long as it's all multiplied, you add the numbers together. So 3 plus 4 is 7, plus 5 is 12, so my answer is x to the 12th power. Okay, so just make it a little more complicated. 2x to the third power times 4x to the 7th power times 3x times 3x. Okay? So they all are x's, and then of course the coefficients in front are 2 times 4 is 8. That's 8. 8 times 3 is 24. And then 3 plus 7 is 10. Plus, again, this is a 1. Don't forget that, is x to the 11th. So that's my answer, 24x to the 11th. And let's do a few more examples. Of course, if I have multiple variables, let's say I have 2x to the 3rd, y to the 4th, z to the 5th, times 4x squared, y, z to the 10th. Right? The number, that's multiplied together. So that's 8. And then you look at the same letter. So it's x to the 3rd, y to the, or sorry, x to the 3rd, x squared. So it's going to be x to the 5th. And then we have y to the 4th and y, so that's y to the 5th. And we have z to the 5th and z to the 10th, so it's z to the 15th power. And that's your answer for that problem. Okay? These problems are actually pretty easy to do. You just have to make sure you get the right, understand what you're doing. With the numbers, you multiply it like normal. It's like if I just said 2 times 4, well, you'd tell me it's 8. Well, and same thing as x squared times x to the 5th is x to the 7th. So I put it together. I have 2x squared times 4x to the 5th. Well, there we go. There's your 8, and there's your x to the 7th, and that's your answer. All right, so don't add the 4 and the 2 together. It's really bad to do that. Okay, so that's basically doing a lot of multiplying. Whenever you multiply, you add your exponents together. Real quickly, which I didn't mention that, let's talk about some terminology here. I used this already, but I think it's good to mention again. 2 is your coefficient. And that's the number in front of the first variable. Okay? This guy right here, that x, that's called our base. It's on the bottom. It's like a base of a building. The base holds up the building. That x is holding up that 3. So that's called our base. Okay, and then of course you already know this is our exponent. All right, so those are just a couple definitions. All right, let's talk about when you have a power to a power. And this is what I mean. X squared to the 3rd power. So it's an exponent and then another exponent on the outside. So I call this a power raised to a power. So power to a power. Okay? What you need to realize is, remember when we talked about like x, if I said x cubed, you said that was x times x times x. So x cubed is x times x times x. So basically whatever this is, it gets repeated 3 times. So if I have x squared cubed, it's just saying x squared is repeated 3 times. Okay, and then of course we know our rule already. Same variable, we add the exponents. So x squared times, or x 2 plus 2 plus 2 is x to the 6th. All right. So again, it's kind of a pain to have to do that right out each time. So if you just look at the rule, what do you think? You have a 2 and a 3 and you get 6. Well, okay, so a power raised to a power, you want to multiply your exponents. That's huge. So if I have x to the 5th raised to the 7th power, that is just going to be x to the 35th power. Pretty simple. Okay. Okay, so let's try a couple more here. X to the 5th, y to the 3rd, z to the 4th, and that is raised to the 7th power. So really what I want you to do is every term inside of there gets raised to the 7th power. And so I'd like you to do is x to the 5th to the 7th power. Write it out each term. And I know some of you are like, well, geez, I really don't want to do that. It's a lot more work. But I've seen it happened in the past where people they leave things out. So initially, that's what I want you to do. Later on, if you can do it without actually writing all this out, that's great. But right now, in order to get full credit, I want to see all this work. So y to the third to the seventh and z to the fourth to the seventh. So then that's just equal to x to the 35th, y to the 21st, z to the 28th. That's it. That's your answer. Okay. So let's put a number in front of there. How about 2x to the 7th, y to the 4th, and raise that to the third power. Okay, well, even before we get to that, let's talk about 2 to the third power. 2 to the third power is just 2 times 2 times 2. That's equal to 8. Please do not think this is 2 times 3, which is 6. That's really bad. Very bad. So don't do that. That's saying 2 cubed. 2 times 2 times 2 is 8. Remember on your calculator, that's like using your calculator with the little up arrow. That's your caret button. So 2 to the third power is 8. Or you have other calculators, 2y to the x, 3, or 2x to the y, 3. They all give you 8. All right? So I told you guys I want you to write it out. So it's going to be 2 to the third power, x to the 7th to the third power, y to the 4th to the third power. So 2 cubed is 8, x to the 21st, y to the 12th. And that's your answer to that problem. Okay, but again, please don't multiply 2 times 3. It's 2 cubed, which is 8. All right, so let's try a couple more here. 3xy cubed z to the 4th. And that's going to be raised to the third power. You know, numbers get bigger, so I don't care, use your calculator, but it's really saying 3 times 3, which is 9, times 3 is 27. So it's 27. Actually, let's write it out here first. 3 cubed, x cubed, y cubed, cubed, and z to the 4th cubed. So that's going to be equal to 27. 3 times 3 times 3 is 27. X to the cube, or x to the third, y to the 9th, z to the 12th. There's your answer. Okay, it's very simple. I'm just going to make a general rule for all the problems that you're going to be working on. You will never leave a base number with an exponent. So please do not leave anything as 2 to the 5th power. If it has a number with it, you better stick this in your calculator and tell me that the answer is 32. Okay? I've seen that on quizzes and tests. Kids always leave a number like that because they're like, oh, gee, it's so big. I mean, I don't even care if it's like, 3 to the 10th power. I don't expect you to know that by heart, but what I do expect you to do is to type that in your calculator and tell me it's 59,049. Okay? I just put it in my calculator when I did this problem. All right, so you need to make sure that you never leave it as 3 to the 10th or 2 to the 5th power. You always give me a number with an exponent as just a number, okay, as a final solution. It's very important. Okay, so let's kind of continue on here. If I did just with a number, then 2 to the 3rd power times 2 to the 4th power. Now, just like if I did x to the 3rd power times x to the 4th power, you left the x's alone, right? Didn't you just say, oh, that's x to the 7th power? Okay, you didn't say x times x is x squared and then to the 7th power, right? You never did that. So this same thing with numbers. It's 2 to the 3rd times 2 to the 4th. You take the 2 and you keep it the same. It's 2. And then it's 3 plus 4 is 7. Okay? So you left the 2 alone because they're both base 2. And then what you do is put in your calculator, 2 to the 7th power is 128. Okay, so it's very simple. 3 to the 4th times 3. Well, that's, again, what number is right here? There's a 1 there. So it's really 3 to the 5th power, which is 243. Okay, no numbers with exponents, ever. Variables, obviously they have to, because you can't simplify x to the 8th power. X to the 8th is x to the 8th, but 2 to the 8th, you can simplify that to 256. All right? Pretty straightforward, but you got to remember the rules. So let's deal with just a little more complicated one. 2x to the 5th, y to the 4th, z, and that's all to the 3rd power, times 3x squared y to the 10th power, and that's squared. So what I want you to do is, you're basically going to have 1, 2, 3, 4, 5, 6, 7 parentheses. You'll have 7 sets of parentheses because I want you to show all your work. So you're going to say, oh, okay, 2 to the 3rd power, x to the 5th to the 3rd power, y to the 4th to the 3rd power, z to the 4th power, to the 3rd power, sorry, 3 to the 2nd power, x squared to the 2nd power, and y to the 10th to the 2nd power. Okay, so 1, 2, 3, 4, 5, 6, 7. 7 sets of parentheses. Let's multiply it all, or raise everything to the power. So 2 cubed is 8. Remember, it's 2 times 2 times 2. It's x to the 15th, y to the 12th. I'm multiplying these exponents. Z to the 3rd, and then that's the first set. And then it's going to be 3 squared is 9, not 6. It's 9. X squared is x to the 4th, y to the 20th. Okay, and then you combine them all together. Remember, you combine the numbers together. So we have 72. X to the 15th times x to the 4th is x to the 19th. Y to the 12th times y to the 20th is y to the 32nd. And there's no z here, so we just say z to the 3rd. And that's your answer. Looks kind of big and nasty, but if you follow all the right steps, you'll be good to go. Okay, so let's just do one more over here. X squared y to the 8th power and times 3x y to the 3rd power. Okay, well, we have x squared to the 8th, y to the 8th, times 3 cubed, x cubed, y cubed. Oops, that's supposed to be on the other side. Okay, and then let's multiply it all out. So it's going to be x to the 16th, y to the 8th, times 27, x to the 3rd, y to the 3rd. And then you put it all together. Now there's no number here, but it's just like saying a 1 over there. So 27 times 1, 27, x to the 19th, y to the 11th. That's your answer. Okay? Pretty straightforward. Okay, now the last topic for the first day of exponents is when you have negative values. So let's talk about that. If I have negative 2 squared, now I know what you want to say is you want to say the answer is 4. But the way I have it written, that's not true. Because remember, you do order of operation, and we do exponent first. And this is really saying 2 squared. And then it's times like a negative. So it's got a negative in the front of it. So the answer to this problem is actually not 4, but it's negative 4. And that's only because we have the negative on the outside, and that negative is not being squared. It's just the 2. So let's look at a couple scenarios. We have negative 2 squared is negative 4. And what about this one now? Negative 2 squared. Now what's being squared? Actually, the negative 2 is being squared. So the answer is really 4. Now the beauty of the calculators that actually have the display where you type things in and you see exactly what you type in is if you put the parentheses in there, you're good to go. If you don't put the parentheses in there, if you type it in just this way, it'll give you -4. And if you type it in just this way, it'll give you +4. So try it out in your calculator. Okay, pause this thing, try it on your calculator, make sure you understand your calculator. Now if you don't have a display, where it displays each individual thing you're typing in, if you type in -2 squared, it'll actually give you +4. So you can't rely on that. You have to understand a little bit about that. That it's not going to give you the correct answer all the time because it thinks you're typing in -2 and you're squaring the -2. It doesn't know that you're putting a negative in after it. So know your calculator. Okay, test it out because it's bad when you get into a test and you're getting them wrong because you don't understand what your calculator is doing. All right, so that's another scenario here, and here's another scenario: negative and then 2 squared. Well, this one's a little more obvious because this one you can even see that their negative is not even being squared. So it's 2 squared, which is this guy here is 4, and then it's -4. So those are your two scenarios: negative without a parenthesis, with a parenthesis with the negative inside, and then parenthesis with the negative on the outside. And that's what your 2 scenarios are, or your 3 scenarios. Okay, make sure you understand them and know them for a quiz and test. So let's talk about if I have -1 squared. You agree that's +1 because it's like -1 times -1 is +1, and -1 to the 3rd power. That's like saying -1 times -1 is +1 times -1 is back to -1. And if I keep going here to the 4th power, it goes back to 1. -1 to the 5th power, -1. Okay, so I want you to understand the pattern. If you have an even, and this is only if it's in parentheses, so if you have an even exponent, like that -1 squared, -1 to the 4th, -1 to whatever even power, if you have an even exponent, the negatives become positive. Because you have an even number, and if it's -1 times -1 is +1, that's even, and then it goes back to -1, back to +1. So just kind of keep that in mind. That's something kind of a good thing to know. So you have an even exponent, the negative becomes positive. If you have an odd exponent, the negative stays negative. Okay, so for example, up here in the right corner, if I have -1 to the 10th power, it's an even number, +1. Now obviously if you have a number other than 1, if it's like 2 or 3, you actually have to figure out what 2 cubed is and 2 to the 4th and 2 to the 10th is. Okay, but -1 to the 101 power. Okay, that's pretty easy. It's an odd number, so the answer is -1. -1 to the 1004th power, even number, answer is 1. Okay, pretty easy stuff. Just again, you got to know what you're doing here. Okay, so let's try some with some variables. If I had -x to the 105 power, okay, that is really saying. Remember, I told you to break it up, and if you have a negative, it's really like saying a -1 there. And you know what? Write it out as -1. And then you could say, oh wait, gee, I have an even or an odd number with a negative, so the answer is going to be -1 or negative, and then that's x to the 105. That doesn't change because you can't do anything with that x to the -1 or x to 105. Okay, let's try another one here. -x to the 5th raised to the 104th power. All right, well, that is -1 to the 104 power, and then x to the 5th to the 104 power. Now this part's actually, the first part's easy. That's just saying it's positive. So I'm just going to write, I'm not even writing anything there. And then it's basically saying, remember, a power to a power is you multiply. So 5 times 104 is 520. So the answer to this one is x to the 520th power. All right. What about negative x cubed? Yeah, let's make it x to the negative 30th. Well, that's an odd, or it's an even power, but that is not in parentheses. So that is like saying negative 1 times x to the 30th, which is just negative x to the 30th. It doesn't change. That's different than this, guys. That's completely different. Now you're saying negative 1 to the 30th, x to the 30th. That's positive 1. The answer is x to the 30th. So watch that. Watch the parentheses. Very important. Okay, what about this? Negative parentheses, negative x to the 8th power. Well, again, this negative is on the outside of the parentheses. That's not being affected. So I'm just going to leave that negative on the outside. I'm going to write negative 1, because remember that's a negative 1. Negative 1 to the 8th, x to the 8th. Okay, I'm going to keep that negative on the outside like that. It's negative, and then negative 1 to the 8th is positive 1. That's x to the 8th. Oh, so there's our answer. Usually don't write the 1 in there, so it's negative x to the 8th, and that's your answer to that problem. Okay? Very straightforward, but the negatives are probably one of the more confusing things with these exponents, and you just got to be careful. Okay, if it's not in parentheses, it doesn't get cubed or squared. It doesn't get raised to that power. If it's inside the parentheses, write it as a 1, and then figure out if it's even or odd. All right. So here's another one here. Negative 2x to the 4th, y to the 5th, to the 3rd power. So it's pretty easy. Negative 2 to the 3rd, x to the 4th to the 3rd, y to the 5th to the 3rd. And again, if you put that in your calculator, be careful, use the parentheses, but think about it. Is it going to be positive or negative? Well, it's going to be negative because it's an odd power. And 2 times 2 times 2 is 8, so it's negative 8. Then it's x to the 12th, y to the 15th. Okay, what about this one? Negative 3, xy to the 7th to the 4th power. Split it up, guys. Negative 3 to the 4th, x to the 4th, y to the 7th to the 4th. Okay. Now remember, it's 3 to the 4th power. It's in parentheses, so it's positive 81, x to the 4th, y to the 28th. If that wasn't, if it was the exact same problem, and it was like this, negative 3xy to the 7th, you do all your work, to the 4th power, you do all your work, that negative just hangs out there on the outside, and then it's 3 to the 4th, x to the 4th, y to the 7th to the 4th. So you'd get negative 81, x to the 4th, y to the 28th. Okay, one last guy here. If I did negative parenthesis negative 3xy to the 7th to the 4th power. Okay, now I got a bunch of negatives. Please, this is really important. You cannot combine these together because people want to say, oh, hey, there's two negatives together, and so I can combine them together, and then it becomes positive. You can't do that because that's multiplication first. You have to do your exponent first. So I'm going to leave the negative on the outside. And negative 3 to the 4th, x to the 4th, y to the 7th to the 4th. So it's negative, and that's 81. X to the 4th, y to the 28th, and then the negative stays there. So it's negative 81, x to the 4th, y to the 28th. Okay? So here, I got like two more to do. I just want to do a bunch of examples with you just so you get the idea of what's going on here. So negative, parenthesis, negative x to the 7th power. Okay, it means it's negative. That's that negative right there. And it's negative 1 to the 7th, x to the 7th. So that gives me negative 1 to the 7th is still negative 1 because it's an odd power. X to the 7th. Now I have no more exponents with these guys here. So negative of a negative is a positive. So my answer is just x to the 7th. Okay. And let's see, I think I want to do one more quick example and then I'm done. So negative x squared times negative y to the fourth to the third power. Okay, it looks complicated, not a big deal. There's no work here, guys. That squared is just the x squared. There's no work at all. So I'm just going to write that as negative x squared. And then it's times negative 1 cubed and y to the fourth cubed. So let's keep rewriting it. Negative x squared. Negative 1 cubed is negative 1. It's an odd power. That's y to the 12th. And then combine terms. Well, here's your negative and here's a negative, so it's positive, and it's x squared y to the 12th. Remember, you can't combine those together because they're different letters. Okay. Anyway, that's it, math fans. So we have the next day is actually more of exponents and just a little, almost the same stuff and a little more complicated problems. But that's kind of the deal. All right. Have a good day.